All right, let's talk about glycolysis. Glycolysis is the first metabolic process of cellular respiration. It is a catabolic process, meaning that we are breaking something down. That something is glucose. When we're looking at the chemical structure of glucose, it's composed of 6 carbons, 12 hydrogens, and 6 oxygens. The only thing that we really care about is the 6 carbons. So glyco meaning glucose, lysis meaning breakdown. So this is the breakdown of glucose. Glycolysis happens in the cytoplasm or the cytosol of prokaryotes and eukaryotes. The main job of glycolysis, the goal that we want to achieve through glycolysis, is the conversion of 2-pyruvates. We want to break down glucose, a 6-carbon structure, into 2-pyruvates, meaning being a 3-carbon structure. We're also producing 4 ATP molecules and NADH. And then right after glycolysis, we go to Krebs, and then we go to the electron transport chain. So let's talk about the reactions of glycolysis. So the first thing is that glucose is converted into glucose 6-phosphate via hexokinase or hexokinase. Hexokinase takes a phosphate from ATP, which turns ATP into ADP, and that allows for the conversion of glucose to glucose 6-phosphate. So we're actually using ATP in this reaction. Right after that, glucose 6-phosphate gets turned to fructose 6-phosphate through isomerase. That's a fairly simple reaction. There's not much going on here. Right after that, fructose 6-phosphate gets converted to fructose 1,6-bisphosphate. We are using energy in this, so phosphofructokinase is going to take that phosphate group, which is going to allow for the conversion of fructose 6-phosphate to fructose 1,6-bisphosphate. Okay. After that, fructose 1,6-bisphosphate is going to break down into glyceraldehyde 3-phosphate and dehydroxyacetone phosphate via the enzyme aldolase. This is the first phase of glycolysis. So the first phase of glycolysis, we're not actually producing any energy or any ATP. We're just using energy and ATP, which is going to lead us into the second phase of glycolysis, where we actually are going to be producing energy. Okay, so now that we're in the second phase, it's important to know that the second phase of glycolysis happens twice. So all the reactions and products that are going to happen in this are happening 2 times. So in the first reaction, glyceraldehyde 3-phosphate is oxidized to 1,3-bisphosphoglycerate. The enzyme that is going to be catalyzing this is GL3P dehydrogenase. In doing so, NAD is going to be reduced to NADH. So NAD is going to take the electron that was released from G3P. This is G3P. And it is going to take that and it's going to turn into NADH. So when something is oxidized, so this is getting oxidized to this, it's losing its electron. NAD is going to be the acceptor of that, and it's going to pick it up and it's going to turn into NADH. There's also an inorganic phosphate that gets added to the G3P. So this is the G3P, which is going to convert it into 1,3-bisphosphoglycerate. So this is going to get attached here, and it's going to turn into 1,3-bisphosphoglycerate. After that, 1,3-bisphosphoglycerate is going to turn into 3-phosphoglycerate via phosphoglycerate kinase. In doing so, again, ADP is going to receive a phosphate group from this enzyme here, and it's going to turn into ATP. So boom, we have generated ATP. After that, 3-phosphoglycerate is going to turn into 2-phosphoglycerate from phosphoglycerate mutase. Fairly simple reaction. So nothing much going on there. And then 2-phosphoglycerate is going to get converted to phosphenolpyruvate. Enolase is used to catalyze this, and a magnesium ion in its +2 oxidation state is also used in this reaction. So that is getting converted to that. Afterwards, phosphenolpyruvate is going to turn into pyruvate through pyruvate kinase. Same sort of deal here. The phosphate is going to get added to ADP, and it's going to transform into ATP. And then remember that this happens twice. So this reaction here is going to happen 2 times. So we're generating 2 pyruvates and 4 ATP molecules. Right after this, we go to Krebs, and then we go to the electron transport chain. I know this was probably a lot, but I hope I made this very brief and easy for you guys to understand. And yeah.